Oh, we're recording. Wow. So I can see Silver Spring, Glory, Genesis, Wamuini, and Shama. I don't know if the others are coming, but if they're not, well, tough. They will be.
Kabiro, they have an apology. They won't make to join today.
Who was that? Sorry.
It's John.
Yes, sorry, John. Who made an apology?
Oh, okay.
Okay, thank you. That's very good. Thank you very much, John. That's very helpful. Okay, guys, so we're going to start. They can watch this later if they want. I'm just going to mute Wamuini in case they come in. Okay, we're starting with a presentation. Today we are going to do about empirical and molecular formulas and how to find them. They are not terribly difficult, but they are very important how you do them. We're going to look at some examination questions based on that. Many of the moles questions in KCSE examinations are empirical formula. Can anybody tell me what empirical formula is? Somebody switch on the microphone and tell me what empirical formula is. I'm sure you know. Come on, Glory, wake up. Come on, Wamuini, get your camera on. Genesis, can anybody tell me? Silver Spring, can anybody tell me? Shama, tell me what empirical formula is. Anybody tell me? No? Have you heard of empirical formula? Yes, no. So Silver Spring have heard it, Shama have, Genesis have, Glory. Oh, poor old Glory. Glory don't have thumbs anymore. It's a shame, but they just can't rate. Good, thank you very much, Glory. Okay, here we go. So you know what an empirical formula is? The empirical formula is the simplest formula. Whole number ratios of the atoms in the formula of a molecule. Okay, we'll see what it is in the PowerPoint in just a minute. So I'm going to share my screen, hopefully. So this is, excuse me, this is what we're doing. This is the second lesson on moles. And it's all about empirical and molecular formulas and using Avogadro's number, which I will just hint at, and using some examination questions to practice. Okay, don't bother writing that down. There's no point. So what we're going to do first is we're going to look at some empirical formulas. As we said, it's the simplest ratio of the atoms in a molecule. Okay, the simplest ratio of atoms in a molecule. If you don't already know that, it might be worth writing down. Genesis Joy, you're looking very smart today. Well done. Simplest ratio. Silver Spring, sorry, just in case. Silver Spring also looked very smart. Well done. Yeah. Simplest ratio of atoms in a molecule. Everybody else is going, but we look smart as well. Yes, yes, you do, Shama. Well done. Yes, you do. Glory, whatever. The simplest ratio. Okay, so I'm going to try and do this partly by questions. So we'll see. So glucose, C6H12O6, very important to us. If we simplify it, it becomes CH2O. So the molecular formula C6H12O6, that's the number of each atom in the proper molecule. Simplest ratio, CH2O. You might say, what is the point of having empirical formula? It is because a lot of the machines, the analytical machines, can only tell us the empirical formula, not the molecular formula. Okay, so here we are. Speed test. What are the empirical formulas for H2O2, CuSO4, C2H4O2, C6H6, H2SO4? Have a go now. Talk to somebody next to you. Do share your ideas with somebody else. Have a look what you think they are. What's the simplest version of H2O2 and so on? That's hydrogen peroxide, copper sulfate. C2H4O2 could be several things, but it's probably vinegar and ethanoic acid, an alkanoic acid. C6H6 is benzene. H2SO4 is sulfuric acid. So what are the empirical formulas for these? I'll give you the answers in just a minute. Oops, sorry. I'll give you the answers in just a minute, just so that you can make sure you can do it. I know a lot of you work on your own a lot of the time. It is good to talk about your answers as well. Yes, let me see it again, Genesis. Yes. Not the last one. Not the last one. Everything else was okay. That was very good, Genesis. Very good. Not the very last one. Oh no, she's so cross. Just have a look at that last one again. Okay, here come the answers, guys. So the first one we can simplify by dividing by 2. So the first one, hydrogen peroxide, becomes HO. The second one, we cannot simplify. Whenever we have just one atom of something like the Cu or the S, we can't simplify that, so it stays the same. So CuSO4. The next one, if we divide it by 2, we get CH2O. So it's CH2O. The next one we can divide by 6 and it becomes just CH. The last one, it looks like we might be able to divide by 2 until you realize that it has S singly and therefore it is H2SO4. We cannot simplify H2SO4. Okay, next page. This is a silly way that I teach my classes how to do empirical formulas. And we have a doctor here, and her name is Dr. Empirical. And what we have to remember is I'm Dr. Empirical. And what we're really remembering is IMDR. IMDR. So those letters, IMDR, there, that is the important bit, because this is what we do. Here's an example. If you can do empirical formulas, you can just carry on and do this while I show everybody else how to do it my way. So if you can already do empirical formulas, I do not want to tell you a different way of doing it. But if you're not very confident, this is my method. Okay, so here we go. This is my method. So IMDR goes like this. IMDR stands for information, moles, divide, ratio. So in this here, we need to find the information, then work out the moles, then divide by the smallest number of moles, and then find the ratio. And it looks like this. So the information is that Fe with a RAM of 56 is 70%, and O with a RAM of 16 is 30%. Moles from the first triangle, if we had 100 grams of this iron oxide, then it would be 70 grams of iron and 30 grams of oxygen. So we pretend the percent is grams. So we go, okay, moles is grams. Remember moles, RAM underground. So if I want the moles, it's grams over the RAM. 70 over 56 is 1.25, and 30 over 16 is 1.875. Then I divide by the smallest. So I've got 1.25 and 1.875. So I divide them both by 1.25. So that the Fe becomes 1 and the O becomes 1.5. Now we can't have 1.5 oxygens. We have to have a whole number. We do not round it up or down. We do not approximate. So we just say, okay, what's the closest whole numbers? What can I multiply it by? Always try by 2 first. Multiply by 2, it becomes 2 and 3, and therefore the formula must be Fe2O3. So I'm doctor is IMDR. Write down the information, which is the percentage or the mass, then find the moles, divide by the smallest, and find the ratio. Okay, here's one for you. Okay, here's one for you. So there are 3 here. You can do any one of them. Try 1, 2, or 3, and I'm going to give you some minutes. I might give you, let's say, 4 minutes. Okay, I'll give you 4 minutes and try number 1, 2, or 3. Remember, it doesn't matter whether it's percentages or masses. It works exactly the same. Okay, the first one is the simplest. The second is a bit more difficult. And the third one is the toughest yet. Have a go at them. Okay, have a go at one of them. It doesn't matter which one. Doesn't matter which one. Just have a go at one of them. Two and a half minutes left. If you have already completed one, then try another one. Just remember IMDR. IMDR. Too easy for the people in Genesis. Much too easy. We've got about a minute left. So can you just show me if you have done at least one of the questions? Could you just show me, comme ça? Could you just show me that you have done at least one? Excellent, excellent. Well done, Silver Spring. Well done, Shama. You guys are really good. Glory, can you just hold it a little bit closer, please? A little bit closer. Even closer. Well done. Excellent. Well done. Okay, people are getting it right, which is really good. Well done, Shama. That's very good. I'm very impressed. Okay, so I'm going to now give you the answers. I'm going to show you the answers. Everybody who did the first one that I have seen got it right. Here we go. So in the first one, we've got the from this first one here. The first one was carbon 52, hydrogen 13, oxygen 35, and it works through and it comes to as 2, the numbers come through as funny numbers, not very helpful numbers. 4.13, 4.35, 13, 2.175, divide by the smallest, comes out as 2 carbons, 6 hydrogens, and 1 oxygen. So C2H6O, which is really good. In the second question, it has an oxide of copper, and it tells you that it was reduced. So we start with 1.59 grams of copper oxide, and it goes down to 1.27, which is the copper. Now that means that the difference is the oxygen. So 1.59 is the mass of the whole compound. That's very important. You've got to recognize, you've got to see what they're doing in the question. So it's got the copper oxide 1.59. Afterwards, it's 1.27. That must be just the copper, which means we have 0.32 grams of oxygen. Okay, that's how it works. So here we are. So 1.27 grams of copper, 0.32, which was the mass which was removed. So it comes out as moles, comes out as 0.02 and 0.02, which is 1:1, which is CuO, copper 2 oxide. In the third one, it asks you, it gives you percentage, but this time it has 3, and that's not a problem. That's the same as the one at the top. And then it says its RMM is 180. So if you work out its empirical formula, comes out as C9H8O4. And if you add up those rams, it comes to 180. So the molecular formula is the empirical formula. Okay. Molecular formula. Here are some examples of working out the molecular formula from the empirical. So if we have an empirical formula HO, but its RMM is 34, what's its molecular formula? Well, all we have to do is this. We say, well, if it is HO, that would weigh 16 and 1, which is 17. So if the empirical formula was the molecular formula, then it's important to go, okay, it would weigh 17. But we are told the RMM is 34. So that's 2 times 17. And therefore we need 2 HOs, which makes it H2O. Okay, that's how we do it. Very important that. Let's just make sure we've got that. We look at the empirical formula here at the top, HO, and we work out what its RMM would be. So it's just 1 hydrogen and 1 oxygen, which is 1 and 16, which would weigh 17. Well, 17 is not 34. So we take the RMM and we divide it by the empirical formula's RMM. So 34 divided by 17, and it tells us 2. So it's H2O2. Question: why is it not 2HO? If we say we need 2 HOs, why is it not 2HO? What is the difference between H2O2 and 2HO? Excuse me, anybody tell me. What is the difference between H2O2 and 2HO? Anybody tell me?
Excuse. Okay. As by my own, I think when we say 2HO, we mean two atoms of hydrogen oxide. But when we say H2O2, we means 2 moles of hydrogen and 2 moles of oxygen.
Joined together, exactly right. So H2O2 would be 1 hydrogen attached to an oxygen, attached to an oxygen, attached to a hydrogen. HOOH, or 1 molecule. If we wrote 2HO, that means 2 separate 1H attached to 1O. Okay, that's very important. Okay, let's carry on. So hopefully you've got the beginning of that. Here we are. Okay. So here are some where you're asked to work out the molecular formula. Here are three. Have a go at these three. They're quite simple. It tells you the RAMs afterwards. There's the empirical formula. Here are the RAMs. Have a go, see if you can work out what the molecular formulas are. Just give you a short time to do that. Do talk to somebody else. Do share your ideas with somebody else. Silver Spring, bad news. There's most of you in Silver Spring are working really well. There's a guy on the second row who's more interested in talking to somebody else, which is good if he's talking about chemistry, but only if he's talking about chemistry. Oh, so thank you for waking him up. That's very nice. That's very funny. Oh, wow. Oh, wow. I'm very impressed by the speed there. Very good. Yeah. Very good. We don't need much help with this. That's really good. Teacher John's team. Wow. Excellent. Shama on target. Yes. When you've done the first one, do the second one. Show me again, Silver Spring. Show me up a bit, up a bit. Yes, nice one. Oh, and the second one. Well done. First and second to Silver Spring. Glory. Yes. Yes, well done. Good. Excellent. If you're not quite sure how to do it, ask the person next to you. Very good. Well done. Well done. Okay. Everybody stop just a minute. Everybody stop just a minute. This is something I do in my classroom. Oh, I say, well done, Shama. Shama first to the third one. Listen, this is something I do in my classroom. Every so often, we know that one student understands it, can do it really easily, and I can't. So what we do is we have a moment where we say, okay, we're going to carry on competing it, but if you need a hand, put your hand up. And if somebody else in the room already knows how to do this, they will come and help you. In other words, if you already know how to do it, you don't have to do all three. Yeah. If you can do it and you understand how to do it, you could go and help somebody else. And that is really important, because if we teach somebody something, we have to understand it. So next time we do a calculation and you're not sure, put up your hand and see if there's somebody around who can help you. Okay, so we'll just finish these. Here they are. So the first one, oh, well done. That's very good. You guys are very good at this. That's very good. Excellent answers from Silver Spring, from Genesis Joy, from Shama. Everybody doing really well. Sorry, could I see that again, Shama, please? Up a bit. Spot on. Well done. Excellent. Excellent, guys. Really, really good. So the first one comes as C4H8O4. The second one comes out as FES. And the last one comes as C2H4Cl2. Okay. So there they are. C4H8O4, FES, C2H4Cl2. Well done. Very good. So here are two proper examination questions. These are proper KCSE questions. One of them came from, I think this is 2018. The one on the left, the one on the right, I can't remember. The one on the left is quite straightforward, is fairly not easy, but it's okay. The one on the right is much harder. If you want a challenge, do the one on the right. If you are still finding this a bit scary, do the one on the left. The one on the right, for those people doing it on the right, you need to use two of the triangles we met last time. The one for gases, which is the oxygen, and the one for masses, moles rem underground, for the H2O. So you work out the moles of CO2 and the moles of water, and that will tell you what is happening. I will show you it in a minute. So let's take 4 minutes to do this. That's about how long you would have in the examination. So I'm going to set a little timer going, and we will see what happens. So I have a little timer going, and let's see who can do any of these. Don't forget IMDR. I'm Dr. Empirical. IMDR. Information, moles, divide, ratio. The one on the left, number 1, is fairly straightforward. The one on the right is pretty tough. Right. Is that the molecular formula, Shama? Is that because it says 2 parts, A, the empirical, and B, the molecular formula? I like the way you're working, guys. I like the way you are working. Okay, if you're not sure how to do this, I want you just to ask somebody next to you. Okay, if you're not quite sure, up a little bit, Janjade. Oh, wow. Excellent. Now you can have a go at the next one. Well done. That's very, very good. Glory, let's have a look. Yes, very good. Don't forget to write down the empirical formula as well, because it said part A, what is the empirical formula? But that's very good. Yes. Excellent. Have a go at the other one. Have a go at the other one. It is more testing, the other one. Okay, those people who have already done question 1, I want you just to help anybody who needs it now, just for a moment. So if there is a student who doesn't know how to do question 1, could you just put up your hand just for a minute? Will you just ask for some help? Right. Could those people, listen please, listen everybody, those people who did question 1 and got C2H40 and C4H802, look in the room and see if you can find somebody who needs some help, please. Just look behind you and just find somebody who needs a hand, because put up your hand if you need some help, please. Guys, in Genesis Joy, there are people who need a hand. Please help. Somebody can help them there. Otherwise, I will have to do it, but I think you can do it at least as well. Wemwini are as confident as ever. We never need help in Wemwini. Oh, not quite. Not quite. Silver Spring, just move the page down a bit.
This is the molecular formula, the final one.
Whoops. That's my timer. This of the second of the sub of question 2. No, not quite. No. Look at your empirical formula again. You just go through your empirical formula again. Very good. Yes, Shama. Very good. Okay. So in the first one, if I have 54.55 percentage of carbon, divide that by 12, I have an answer of 4.545. The hydrogen is twice as much, and the oxygen is half as much. And so it comes out as C2H4O. C2H4O. But C2H4O, if you add it up, would only have an RMM of 44. And because it's only got an RMM of 44, that is half what it should be. And therefore it is C4H8O2. I am now going to do the second calculation. Has anybody tried the second calculation? Show me a thumb if you've had a go at the second calculation. No, okay, I'll just write some bits on the board and then I will change cameras, I hope. 2.88. 2.16 grams of water, is that right? Yes, okay. So I'm just going to change my camera. I'm going to stop sharing. I'm going to show you this one, RMM of 84. I'm just going to have to adjust a camera. Get out of the way. Oh. Okay. So just adjust this. Okay. So in question 2, yeah, that's a bit better. Hi, I'll have to bend down. Hello. In question 2, it tells me I have a hydrocarbon, in other words, only carbon and hydrogen, and its RMM is 84. And it asks me what its empirical and molecular formula is. And I've only got this information. Now, this is quite odd information. It tells me I have a certain volume of carbon dioxide and a certain mass of water. That's odd. But if you remember our triangles, for the 2.16 grams, moles equals grams over RMM. Moles ram underground. That equals 2.16 grams over 18. Right, so 2.16 divided by 18 is 0.12. Okay, so I know that I have 0.12 moles of water. Now I'm going to look at the carbon dioxide, and in gases, moles equals the volume that we've got. Whoops, sorry, equals the volume in cubic decimeters over 24 cubic decimeters or liters. Decimeters, cubic decimeters, liters, doesn't matter. So that's going to be 2.88 over 24, and that will be 0.12 moles as well. Now that's important because that means, I hope you can see this okay. Let's move across just a bit. Sorry about a little bit of reflection. That means that the moles are the same. Now, if the moles are the same, then we get the same amount of CO2 and H2O. But we are talking about it burning, okay? So we're talking about it's got a certain number of carbons and a certain number of hydrogens. And when it burns, it forms carbon dioxide and water. And it forms them in 0.12 and 0.12, in other words, 1 to 1. So there's no number here, 1 and 1. Now, that means that the number of carbons over here is effectively 1, but the number of hydrogens, because although there's 1 water, there are 2 hydrogens in water. Can you see that okay? Then that means that there are twice as many here. In other words, the chemical has C1H2. C1H2. Okay. So if it's C1H2 is the empirical formula. Now they quite often do this. They ask you, they tell you, there's this volume of carbon dioxide, that mass of water, and then you have to work out the ratio of the carbons to the hydrogens. So its empirical formula is CH2. CH2 would have an RMM of 12 and 2, 14. But we were told that the RMM was actually 84. So I want 84 over 14, and 84 over 14 is 6. Therefore, it's C6H12. Okay, let's just look at that again. We got the carbon dioxide, it was 2.88 cubic decimeters. We got the water, 2.16 grams. You can't relate cubic decimeters and grams. So we work out the moles, and 2.16 divided by 18 is 0.12. And 2.88 divided by 24 is 0.12. That means 1 to 1. But because carbon dioxide contains 1 carbon and H2O contains 2 hydrogens, the empirical formula must have been 1 carbon to 2 hydrogens. That's where we got that. This would have a mass of 14. We are told the real molecule back here has RMM of 84. So 84 divided by 14 is 6. So I need 6 times CH2, which means that the molecule up here was C6H12. Okay. All right. That's quite a difficult question. I think that's quite difficult. Really quite difficult. Can you see it all? There. Okay. Right. Moving on. Coming back to the other camera, I hope. Okay, that question there is very hard. I think that's very hard. Okay, so if you don't completely get that, do not worry. We are not necessarily aiming at 100% in the examination. We are hoping for a good score, right? We're going to work for a good score, but you don't ever need 100% in the examination. In the UK here, the very top students at Form 4 level, to get the very top grade, they need 85%. That's the really top grade. That is the grade you would need to get to the top universities in the world. Okay, so we do not actually need 100%. That's very important that you realize that sometimes even 60% is really good. So do not worry if you don't get it all. Okay, going back to sharing. Now, in this, hopefully you can see it now. So there's the question. You will get this copy. You get the PowerPoint afterwards. So there it is. Whoops. Here is a question, another, this is a long question. This was worth 6 marks, I think. Oh, no, 4. Oh, sorry, no, only 4. No, my apologies. It's worth 4 marks. This is a KCSE question from a couple of years ago. I'm going to, if you want to do it, you can do it. It is about spotting what you do. So just have a look at it. It tells you that Epsom salts, which is magnesium sulfate, is MgSO4 NH2O. You may know the answer is 7. It's sometimes helpful. You can sometimes know that what the answer is. So here we go. It says that we start with 4.92 grams and we heat it up and we drop it down and the water is evaporated and it goes down to 2.4. And if it goes down to 2.4, then 4.92 minus 2.4 is the mass of water which is gone. Okay, that's the first bit. Then you work out the moles of magnesium sulfate. So 2.4 is the magnesium sulfate. And so 2.52 must be water. Okay, so that's where we go. All right, look at the question and try and answer it. Try and understand it. Let me just explain on the other board. So I'm just going to go to the other board because they sometimes ask you about this sort of thing. So there are two experiments that they talk about. The first one is they take an evaporating basin. It's shaped like this. They put the chemical in it. I can't remember the mass from that, but this is the MgSO4 NH2O. They then heat it, and the water disappears. And so afterwards, you are left just with magnesium sulfate. So the water is gone, the magnesium sulfate is left. So you have a mass that you start with, a mass which is lost, and you have to, what you do is you heat it and you weigh it, and then you heat it again and weigh it some more, and heat it again and weigh it some more until the weight doesn't go down anymore. So you know that all of the water has gone. That's how you do that one. The other type of calculation is based on this, where we get a chemical like copper oxide, and they blow hydrogen in here, and the hydrogen goes through and comes out as water. So the copper oxide loses its oxygen. So you have an initial mass, which is copper oxide, then a mass afterwards, which is just copper. And from that, you can work out how much oxygen there was. So the hydrogen goes through the copper oxide, removes the oxygen. So you have a mass before and then a mass afterwards. And that's how you do it. Okay, so that's how those calculations go. All right. So on that, on the question, which is next on this here. I hope you will be able to see this presentation. You will be able to get hold of this presentation from your supervisors. This one here is that question. I will tell you that the answer comes out as 7. If you want to have a go at it, I mean, if you want to write down the numbers now, you can. To start with, it's 4.92 grams, and it's MgSO4 NH2O, and it drops down to 2.4. And if you work out how its empirical formula, it comes out as MgSO4 7H2O. Okay, onwards. Whoops, sorry. So in this one, this is using 6.023 times 10 to the 23. This is Avogadro's number. In Avogadro's number, what we do is we work out the moles, and we know 1 mole is 6 times 10 to the 23. You are told that number. So if it says how many atoms of Na in 4 grams of NaOH, then it's the moles of NaOH, 4 divided by, this has an RMM of 40, so it's 0.1. So in other words, we have 0.1 moles of NaOH. So let's just have a look at that. Let me just show you that, because this is the last bit that we need to do before I ask you if you have any questions. Okay. So that's the question. How many atoms of Na in 4 grams of NaOH? Well, we know that 1 mole is, 6 times 10 to the 23, 6 with 23 zeros. So if I can find out the moles of NaOH, then I'm mainly there. So moles of NaOH, well, it's in grams. So that's grams over RMM, and that's 4 over 40, which is 0.1. Can you see the end of that board? Yes, which is 0.1. So if I had NaOH and I broke it up, I get Na and O and H. In other words, one of these gives one of those, one of those, one of those. So 0.1 will give 0.1 of that. If I have 0.1 moles of Na and 1 mole is 6 times 10 to the 23, then I don't have 1 mole, I have 0.1 moles, which will be 6 times 10 to the 22. So that's all you have to do. It's nothing problematical. It's really, really not very difficult. I promise, really not very difficult. You work out the moles of the chemical, and then you say, okay, that number of moles times 6 times 10 to the 23. The only difficult thing comes with something like this. So if they say, how many atoms of hydrogen in 18 grams of C6H12O6 glucose, okay, how many atoms of hydrogen, then you know that C6H12O6 will produce 12 H's. One of these will make 12 H's. So I'd work out the moles of the glucose, that's grams over RMM. I could work that out, it is 180, 0.1. So if we have 0.1 here, if it's 1 to 12, 0.1 to 1.2. So then it's 1.2 times 6 times 10 to the 23. Okay? Fairly simple.
Yes.
Hello. You wanted to ask something? Silver Spring?
Just carry on.
Oh, good. Thank you so much. Thank you, Headmaster. Okay. All right. So in terms of moles, that's just about it. I just want to get something else out. Oh, come on. Okay, I have sent your supervisors this. This is proper examination questions. I will just show you some of them now. So they are like this. If I dissolve 3.65 grams of HCl in 200 cubic centimeters of water, what is the concentration and so on? If I have 1 kilogram of benzene, how many moles, etc., etc. Okay, the answers are all at the end. Okay, the whole thing has answers all the way through it and the way that you calculate it. Okay, so this is a big sorry, this question here, whoops, here we there. This one here is quite a difficult questions. These are all KCSE questions, and here are the answers and how you do it and so on. So if you can use your supervisors to show you, then it will make life quite a lot easier. Okay, we're just going to look at one now. Just one of those questions now, because I think we just have time, just about time. I'm just going to show you how to do this one. Okay, just going to show you how to do it, and then you can, when these come through to you, perhaps you will be able to look at them and work out what to do. Okay. Now, these are questions like what we have already done. It's pretty straightforward. And in fact, then they're ones that we have already looked at. Okay. So here we are. So now I'm going to stop sharing that and go to the other screen. So here we are. And after this, I will ask if there is anybody with any questions about anything. Okay. So in this, we have some Mg reacts with HCl to form MgCl2 and hydrogen. And it says I start with 1.96 grams of this and 100 cubic centimeters of 0.2 m of the acid. Okay, and it says the first question is, which one is in excess? Well, for this one, I have a mass. So the moles is mass over ram. So moles equals 1.96 over 24. In this one here, the triangle for solutions was moles at the top, concentration times volume. So the moles equals the concentration, whoops, 0.2 times the volume divided by 1,000. Okay, that one's easy to do in your head because that's 0.1, this is 0.2, so that's 0.02 moles. Over here, 1.96 divided by 24 is not quite so easy. So I'm going to get my calculator.
Excuse.
Yes.
I think the moles should be 0.1. Not
of what?
2.
Of what?
The moles. It should be 0.1.
Of the HCl? Of this? Are you talking about of the HCl?
Yeah, thank you. I now see it. You can cut.
The moles triangle for solutions is moles at the top, volume and concentration. So it's the concentration 0.2 times the volume 100 cubic centimeters divided by 1,000 because it has to be in cubic decimeters. This is 0.1. 0.2 times 0.1 is 0.02, I think. 1.96 divided by 24 is 0.0817. So which one is in excess? This one. The magnesium is in a lot of excess, okay? The magnesium wins. Now that means that if we are then asked to work out how much of one of these we get, we have to base it on this, because this is too much. So the acid here will react with this, but there will be lots of the magnesium left over. And therefore, in one of the questions, it says, what volume of hydrogen is produced? Well, what volume of hydrogen? It will be 0.02 moles of the acid. So so I've got 0.02 moles here. And because it's 2 to 1 and 2 to 1, here I will have 0.01 moles of H2. Yeah, because it's 2 HCl gives 1 H2. And the volume of a gas is equal to the moles times 24 or 22.4. Sometimes they give you that, 24, which equals 0.01 times 24, which is 0.24, which is 240 cubic centimeters. Okay. I've recorded it. If you want to see it afterwards, you can see it. I'm just now going to come off this. All right. Now, you have been very patient. Those are really quite difficult questions. The rest of them, I will just share with you so you can actually see them. There are quite a lot of practice questions with the answers. There are quite a few of them with all the answers, okay, and exactly how you do it. All right, so that hopefully they might be useful if you get a chance to see them. I'm going to say that's about the end for today, because I've finished the moles as far as we can go in this time. And I know for some of you, they will be very difficult and you will be going, oh my gosh, I can't do that. Don't worry, just try to concentrate on the things which you can do. Okay, really try and concentrate on the easiest stuff. It's very important. What I want to do now, just very briefly, is I will allow anybody who has any question about chemistry to ask it. If anybody wants to say anything or ask any questions about some other part of the syllabus, that's fine. If you want to go, that is also fine, because we have had virtually an hour of this, and that's okay too. But I wanted to give a chance to anybody who wanted to ask a different question about organic chemistry or about acids or about metals or something like that. And because I think I was told that you finish on the 22nd or something, and my next lesson would be the next day. So I won't be having another lesson with you until after Christmas, or at least after the examinations. And that means that I need to be here to answer any questions. And your supervisors know how to email me. So if you have specific questions and you need something explaining, I could always write something and send it to you. Okay, that's not a problem. Really not a problem. I want you guys to do well. Like we said last time, to the few people who hung around at the end, you have many, many things which are interesting to you. There are many things which you want to do. You want to work in a job, you want to sleep some more, you want to listen to music, you want to go out with friends and so on. But for the next few weeks, when you have your examinations coming up, you need to give them this concentration. Please give them concentration, because if you can, it will make all the difference. I will say, therefore, Asante Sana, I'd like to say squash banana, but that's wrong. So I will just say goodbye. Yes, some people there. Thank you so much, Shama.
I have a question.
Yes, I know you have. I'm sure lots of people have a question. So if anybody has a question, please stay online. I will try to answer them. Some of your chemistry, which you do, is not in the UK syllabus at all. Not at all. So if you ask me a question, I might go, I don't know. You're going to have to find out. I can work it out normally, but I don't know absolutely everything in chemistry. Only about 99.8% of it. Anyway, so I'll say, yeah, thank you, Wamini. I'll say bye, guys. If you want to stay and ask a question, do. But I really like you students. You work very well. Thank you. So if you have a question, wait. Otherwise, au revoir. A bientôt. Goodbye. See you. Ciao. Kwaheri. Louise. Right. Somebody has a question. Somebody has a question.
Okay.
Oh, hang on. Sorry. I'm just going to stop recording because otherwise it gets too long. So I'll just stop recording.